Hello everyone and welcome to the lecture on the map function in Python. In this lecture we'll look at what the map function is and what it does. The map function applies a function to each element in a given sequence and returns a new sequence as a result. Let's look at an example. Let's say we have a list containing the elements xyz, xy, and z. And let's say we have a function. So what the map function does is it will apply. So we have our map function. It will apply the function, the given function, to each element in our sequence, to each element in our list in this example. So it will apply it to the given list, for instance, and then it will give us a new list as a result. So for instance, if our function finds the square root of the elements in our list, so the result will be the square root of each of the elements. If our function returns the value of a given sequence by, let's say, 10, so the result will be each of these elements in our sequence times 10. So that's what the map function does. Now let's see an example. So we have map, and let's try to find out. Let's try to apply a map function and then convert the elements in our list from uppercase to lowercase. So we can call the strings lower method, str.lower, and then we pass our list, let's say x, upper y, upper z. Okay, that should be good. So we apply strings lower method to this list. So the result will be, if we run this, we get x, y, and z, or all of them are lowercase. So we have a function here, and the map function applies the given function to each of the elements in our list. In this case, to each of the elements in the sequence, and the sequence has to be iterable, right? Great. So this is in Python 2. If you are using Python 3, the map function results an iterable object. In Python 2, it gives you a list, whereas in Python 3, the map function gives you an iterable. So in order to use the map function to get a list in Python 3, you have to cast everything into a list. So we have to say, let me copy that, and then cast everything inside the list. So this would be the equivalent of the map function in Python 3. So if you are using Python 3, don't forget to cast the entire map function inside a list. That way you'll get a list as a result. So that's the difference between Python 2 and Python 3 when it comes to the map function. Great. Let's look at another example. For this example, let's say we want to find the square root of some given numbers. Okay. Let's import the math module, and then what we'll do is we'll try to find out the square root of some numbers in a given list. So we can say map square root, so that will be our function, and then find the square root of these numbers. Let's say 4, 64, 25, and 81. So we know the square root of these numbers. So if we apply the map function, we get, square root is not defined. Okay, let's from math import square root. Okay, let's run it again. Okay, now we are good. So the map function applies the given function, which is the square root function in this case, to each of the elements in our sequence. So the square root of 4 is 2, the square root of 64, 8, 25 is 5, and 81 is 9. Okay, similarly you can add some more numbers. Let's say we can add 23, run it again. So we get the result. That's the map function. And the equivalence in Python 3 would be list and then the entire map function. So don't forget to cast it to a list if you are using Python 3. Let's look at some more examples. Let's define a function that will give us the power of 4. Let's call it power 4, and then it takes an attribute x, and our function will return 4 to the power of x. So basically, if we pass 3, our function will return 4 times 4 times 4. So 4 to the power of 3, basically. Okay, so that's our function. And let's see our function. So power 4, let's pass 3. So this will give us 4 times 4 is 16, 16 times 4 is 64. So we get 64. That's our function. Now what we'll do is we'll use the map function to apply this power 4 function to a given list, to a given sequence. Let's do that. So we can say map and then our function power 4 and apply this power 4 function to the following elements in our list. Let's say 2, 3, 4, 5, and 6. So basically this will be equivalent to 4 to the power of 2, 4 to the power of 3, 4 to the power of 4, and so on. So when we run this, we get 4 to the power of 2 is 16, 4 to the power of 3 is 64, 4 to the power of 4, 256, and so on. Okay, and for Python 3 users, cast the entire map function into a list. Great. Next, let's see how we can use the map function with a lambda function. Okay, so we'll use the same power 4 function, and in this case, let's use a lambda function. So we can say lambda x, then return 4 to the power of x. So we're doing the same thing as we did here. Instead of defining a function, we are using an anonymous lambda function. So lambda x and then return 4 to the power of x, and let's apply our list 2, 3, 4, 5, and 6. So the result should be the same. Run it, we get the same result. So that's how we can use map function with lambda. So map function is used commonly with lambda. Let's look at another example of how we can use the map function with lambda. Let's say we have a list x and contains the element 3, 6, 9, and 12. What we'll do next is we'll return each of these numbers to their power. So 3 to the power of 3, 6 to the power of 6, and so on. So we can say map, then lambda, let's say y, and then return y times y, return y times y, and then we'll pass our list x. So if we run this, we get 3 times 3 is 9, 6 times 6 is 36, 9 times 9 is 81, and 12 times 12 is 144. That's how we can use the map function with lambda. Let's look at a few more examples of the map function. Now what we will do for this example is apply the length function to a sequence in a given list. Let's do that. So we can say map and then apply the length function to the elements in the following list, and let's have a list within a list as elements for our list. Let's say 2, 1. Let's have another list containing the elements 2, 2. Let's add few more list elements. Let's say 3, 4. What else can we add? Let's add 4, for instance. I think that should be good. So what this map function will do is it will apply this function, which is the length function, to each of the elements in our list. So our list has how many elements? 1, 2, 3, and 4. We have 4 elements. So when we apply the length function, the result will be a list containing. So the length of this is what? 2, 2, 2, 1. So that will be our list result. So you get 2, 2, 2, 1, right? Length of this is 2, length of that is 2, and finally length of the last element is 1. Okay, last but not least, let's see how we can use the map function with for loops. We can do that. For that, let's define a function. I'll just call it at func x, and then our function will return x cubed, for instance. X cubed. Okay, let's give it a better name. Q function. Q function of x return x cubed. What we can do is we can say for I in map, and then we'll pass our cube function, and then apply this cube function to the following elements. Let's say 3, 4, 5, 6, and 7, and then simply print I. So for I in map cube function, which we define here, apply it to the elements in this list. So for I in map function, print I. So if we run this, we get each of the elements cubed. 3 cubed is 27, 5 cubed is 125, and 7 cubed is 343. Just to make sure, we can add 10. 10 cubed is 1,000. Right? 10 times 10 times 10. So if we run this again, we get 10 cubed, finally 1,000. So if we only use this map function, we get a list containing. So if we do this, we just get a list containing these elements. Right? But this is an example of how we would use a for loop with a map function. How we would use the map function with a for loop. So it would be the same for Python 3. Great. Just to recap, we looked at the map function, and we saw that the map function takes a given function and applies it to the sequence in a given list, for instance, and then gives us a new list as a result. And if we are using Python 3, don't forget to cast the entire map function into a list, because the result of map function in Python 3 is an iterable object instead of a list. So we have to cast it to a list. Great. Thank you everyone, and I'll see you at the next lecture.